Hello, my name is Nazima, and today we're going to talk about vectors and forces. The four main questions which we're going to talk about is first, what is a vector? Force is a vector quantity. What is resultant? And what is equilibrium? First, we're going to talk about vector. So, what is vector? Vector is an object that has both a magnitude and the direction. Geometrically, we can picture a vector as a directed line segment whose length is the magnitude of the vector and with the arrow indicating the direction. The direction of the vector is from its tail to its head. So if you want to see clearly what is vector, we can demonstrate like that. Arrow line, this is a vector. Everything what is here is a magnitude. This is the top of the vector, which is called head and tail. Overall, the head shows the direction of the vector. Another question. We're going to talk more about force as a vector quantity. So to talk more specifically about it, force can be considered something that either pushes or pulls an object. When a large enough force is applied to an object at the rest, the object tends to move. So it's anything can be used as an example. For example, a box, and the person can either push it or the opposite, pull it. And when a push or pull is applied to a body motion, generally speaking, force can be defined as that which changes or tends to change the state of the rest or uniform motion of the body. When describing a certain physical quantities, there is little value in describing them with the magnitude alone. For example, if we're describing the velocity of wind, it is not very practical to say that the wind has a speed 30 km per hour without specifying the direction of the wind. It makes more sense to say that a wind has a speed of 30 km per hour traveling south. Similarly, the description of a force without specifying its magnitude and direction has a little practical value. Because force is described by both magnitude and direction, it is a vector. The rules are applied to vectors also apply to the forces. So after talking this, we can talk about the resultant. What is resultant? You want to ask me. The simple explanation of what is resultant is the resultant of the several forces is a single force that can be used. It represents the combined effect of all the forces. The individual forces that make up the resultant are referred to as the components of the resultant. To show an example, we have two vectors which are connected to each other. One of them is going to the north, and one of them is going to the east. So if we want to combine both of these vectors, we need to see from which point both of them are starting, and from here we can draw the resultant. Basically, this resultant is combination of the vector which is going to the east side and which is going to the north side. There is two ways how to get the resultant: head to tail, and this kind of combinations when both of the vectors they're directed to the different directions. To show more specific about resultant, we can also use the example with head to tail. So we can draw any vectors which are connected to each other, and the vector which will connect both of them will be the resultant. Okay, after that we can talk about what is equilibrium. Equilibrium is the number of forces is the single force that opposes the resultant of the forces acting in an object. When the equilibrium is applied to the object, this force maintains the object in a state of equilibrium. To have more sense in understanding what is it, I can show the demonstration. So there is a vector A and vector B. A and B. They are making a resultant. Let's just say vector C then. The equilibrant will be a vector which will go to the opposite direction. So that the forces were equally to each other. If we see any examples where the resultant and the equilibrium are both demonstrated, it means that an object is in a state of equilibrium. The form of it is... Why am I getting so fucking nervous every fucking time? Okay. From another picture, we also can say that this 2 represents F vector equals to F A and plus F B vectors. F is this vector. And the equilibrium will be represented as negative F because it's going to the opposite direction, so we need to go backwards. And it equals to the equilibrium vector. To show more examples, we also can use the head to tail, the one which I was talking about earlier, technique. Vector force 1, F2. Both of them, they create a resultant, which is big F. But from here, knowing that this resultant going to the north side, it will go to the opposite way. So again, it will show as the negative F equals to equilibrium. Resultant of 2 noncollinear forces is represented by either the diagonal of the parallelogram determined by these 2 vectors when placed tail to tail, or the third side of the triangle formed when the vectors are placed to tail, as I was talking about it earlier before. So on the images, you already can clearly see how equilibrium is supposed to work in this kind of situations, and that's it.